All right, so today we're going to look at something called stoichiometry. We've been building up to it. We've been looking at converting from formula units to moles and then from moles to mass. The good news, stoichiometry, we don't have to be going into the formula units part. So we don't need to worry about 6.02 times 10 to the 23rd. 6.05, 6.02? Yeah. Really what stoichiometry is useful for is if I have an equation. That's not what I wanted. Let's go there. All right. So let's have 2.02. Oh, see? There I messed myself up. There. No, let's just do that. All right. 2.2 moles of hydrogen plus 1 mole of oxygen gas becomes 2 moles of H2O. All right, I'm on the right track now anyway. So, what stoichiometry is useful for is if I'm given a certain a certain mass of anything, I can calculate out the mass of another substance involved with the equation. So, for instance, let's say that I have 10 grams of H2. 2 grams of that. I can calculate out how much water is produced. And it's going to use the shortcut that's up on your board. So essentially, so if I come over here, so the way that that works is, see if I've got enough room here. Mass of X, and X is what I'm starting with, moles of X. To go from, oh, hang got away from me there. Actually, let's just do this. All right. All right, so there's something wrong with the internet board. That's fine. All right, so go from mass of whatever it is I'm starting with to moles of whatever it is I'm starting with. I'm going to think that starting mass times 1 mole of whatever I'm starting with over, that's going to be really hard to see, the molar mass of what I'm starting with, okay? But that'll be up on the board so you can see it there too. And then, let's say my next step is to go from moles of X to moles of Y. Now to do that, I need a mole-to-mole ratio. That mole-to-mole ratio is going to come from the chemical equation we're starting with. So I'm even going to say from chemical equation. Okay? That's where those two numbers are going to come from. And for moles of Y, to the mass of Y, I take that times molar mass Y, that X there, all over 1 mole of Y. All right. It's kind of the base kind of shortcut thing I'm going to be using here. Starting off with, I have 10 grams of H2. I want to know the mass of the water being produced here. So what I'm going to do is I'm going to take that 10 grams. The first step is to go from mass of X to moles of X. So to do that, I'm going to take it times 1 mole. And X is really just what I'm starting with. So in this case, X is just H2. And so over that, the molar mass of X, so for hydrogen, 2H2. 1 hydrogen has a mass of 1, 2 hydrogens have a mass of 2 grams. Now, when we were converting, I could be a little lax about not incorporating the right units. For the stoichiometry part, we kind of have to make sure that we know what we're talking about here. We need to have those units there. And I'll show you why shortly. All right. So then the next step is to take it times that mole-to-mole ratio, which is going to come from the chemical equation. So moles of Y. So in this case, let's put X there, Y there. From the chemical formula, I can see that I have 2 moles of Y. or H2O, for every 2 moles of H2. All right, so now I'm down here. I just have one more conversion left. That'll be times the molar mass of Y all over 1 mole Y. So in this case, molar mass of Y is H2O. Oxygen, according to your periodic table, has a mass of 16, plus the 2 hydrogens would be 18. So 18 grams H2O all over 1 mole H2O. All right, so now there's a simple check I can do to make sure I did it right. So I'm starting with grams of H2 here, and then I'm dividing by grams of H2, so H2 on top and bottom. Those cancel. Moles of H2 here, moles of H2 here. Those will cancel. Moles of H2O here, moles of H2O here. Those cancel. I'm left with grams of H2O, grams of water, which is what I was looking for in my original question. So now if I get out my calculator, I'm going to take 18 or 10. Let's do it on here. So 10, 2 on top, those cancel, times 18 divided by 2. That becomes 5. 5 times 18, 40. I should end up with 90 grams of water. Pretty easy, right? All right, let's do one more. That's not working. All right, so let me go here. All right, so let's start over. So let's say that this time I have, my equation will be CaCl2 plus oxygen, O2, becomes CaO plus Cl2. All right, first thing we gotta ask for stoichiometry is it balanced? And I can kind of see it's not. 2 oxygens here, 1 oxygen here, put 2 there. Now 2 calciums, 1 calcium, 2 there. 4 chlorines, put a 2 there. All right, now we're good to go. So in this case, let's say that I'm starting with seven grams of O2. This is my X. Let's not put it there though. For now, that's my X. That's what I'm starting with. And I want to know the mass of the chlorine gas produced. All right, so first things first, write down what you're given. So 7 grams. And that's 7 grams of O2. First step, according to that the shortcut sheet, to go from mass of X, or the mass of what you're starting with, to the moles of what you're starting with, is we're going to take our starting mass times 1 mole of what we're starting with over the molar mass of it. So 1 oxygen has a mass of 16, 2 of them have a mass of 32. All right. The next conversion, according to your shortcut sheet, is the moles of Y, or what we're ending with. So in this case, that would be the Cl2 over the moles of X, or what we're starting with, which is O2. And these numbers here are going to come from the periodic table. So the moles of O2, according to the chemical equation, that's only 1. The moles of Cl2, though, are 2. All right, your next conversion then is 1 mole of what we're looking for, so Cl2, over the molar mass of what we're looking for, so Cl2. So over here, I'm going to say 1 chlorine has a mass of 35.5. There's 2 of them here. 35.5 times 2. 1, that's 10, plus the 1. Alright, so that gives me a 1 here. 2 times 3 is 6, plus 1 is 7. 71. Alright, so now I just need to double check to make sure I did it right. Grams of O2 on top, grams of O2 on the bottom, cancel. Moles of O2 on top, moles of O2 on the bottom, cancel. Moles of Cl2 up top, moles of Cl2 on the bottom, that cancels. So I'm left with that, which is what I was looking for. So now I just need to type this into my calculator. This one I'm not even going to try to do in my head, but I do have 7 divided by 32. Come on, calculator. There we go. 7 divided by 32. That'll be times 2 because it's up top. Remember, you multiply anything up top, you divide by anything on the bottom, and then it'll be times 71. And the answer I get is 31. Well, I can say 0.1 or 0.0. Let's make it 0.6 grams of Cl2. So if I'm starting with 7 grams of O2, I'm producing 31.06 grams of Cl2. You know, I'm looking at it, that kind of makes sense. So starting off with, I have about 1/4 of a mole, according to this. And looking at the equation, you know, I produce 2 moles of Cl2 for every 1 mole of O2 I have. So looking at that answer does make sense. Stoichiometry is it's one of those things that's just kind of messy. You just kind of have to keep trying it, keep pushing through, keep struggling with it. Eventually it will click. You just got to keep trying. We're going to be working on stoichiometry for some time. So good luck and have at it.